Hello, my lovelies! It's Susanna, and today I want to show you how to evaluate these logarithms without using a calculator. We start with simple examples, but it gets more and more difficult. But let's start here first. We want to evaluate log base 4 of 16. And for that, we only have to count how often do we have to multiply this number here, the base, we take it, the 4, and we multiply it by itself, and we have to count how often do we have to do that so that we arrive at this number here. So the 16 is our end. So we multiply 4 times 4 equals 16. Okay, we arrived at the end already. And now we just count how often have we multiplied the 4 by itself. It's just 2 times. So this 2 is actually the result of this logarithm. That's it, nothing more. So in other words, we have 4 times 4 here, which equals 4 to the power of 2. So 4 to the power of 2 equals 16, right? So this number is this result here. So calculating a logarithm means to find this exponent here. So 4 to the power of what equals 16? 4 to the power of 2 equals 16. That's it. Just count. So let's take a look at the second example. Log base 2 of 8. We take the base, the 2, and we multiply the 2 by itself. How often? Let's see when we reach the 8. So 2 times 2 equals 4. We're not there yet. We multiply again by 2. Now the result is 8. We arrived, and now we just count how often have we multiplied the 2 by itself. It's 3 times, so the 3 is the result of this logarithm. That's it. Depends on how nice the numbers are. So here we have another base, the square root of 5, but the structure stays the same. We take the square root of 5 and multiply it by itself until we reach this number here. So square root of 5 times square root of 5 equals 5. Okay, we're not there yet. So we have to multiply by the square root of 5 again twice because these together equal 5 again. So now we have 5 times 5, which equals 25. Yes, we've reached our number. So now we just have to count how often we've multiplied the square root of 5 by itself. 1, 2, 3, 4, and the 4 is our result here. So it's easier than you thought, isn't it? What about this? This is super easy because as soon as you have a 1 in your logarithm, the result is always 0. You don't have to take a look at your base, not at all. As soon as you have the 1 here, the result is 0. That is because you take the base, so the 4 to the power of 0 equals 1. And it doesn't matter which number you have here, a number to the power of 0 always equals 1. So you could have the number 5 here or the number 7. It doesn't matter which base you have here. This number to the power of 0 always equals 1. And that's it. So super easy if you have the 1 in your logarithm. Okay, this looks different, a little bit more complicated. We have the base 3 and in our logarithm 27 to the power of 2. Now, before we take the base and multiply it and try to reach this number here, there is a rule for the logarithm that allows us, if we have a power in our log here, then we can take the exponent and move it in front of our logarithm. That's a rule and it's super, super helpful. So before you start, just take a look at if there are some rules that you can use. So this is one of them. So we take the 2 and move it in front of the logarithm. So we have 2 times, and now we write the rest of the log here. So log base 3 of, and then only 27, because the 2, we put it in front of the log already. So now we just have to calculate this here. We take the 2 from here, and now we take the base and see if we multiply the 3 by itself. How often do we have to do that to get to the 27? 3 times 3 equals 9. Times 3 again equals 27 already. Okay, so it's 1, 2, 3. So 3 is the result for this log here. So we write it here, and 2 times 3 equals 6. That's it. Okay, let's take a look at the next example. Here we have a decimal number in our logarithm, and I would suggest to convert this decimal number into a fraction. I know people usually don't like to work with fractions, but there are rules on how to deal with fractions in the logarithm, so trust me, it's not going to be that bad. We take log base 2, and now we convert this decimal into a fraction. For this, we take the number after the decimal point, so the 125, and write it in the numerator of our fraction. And then we divide it by the place value of our last digit here. So these are the tenths, hundredths, thousandths. This is the last digit, so we divide it by 1,000, and this is the fraction to this decimal number. We could work with this now, or we could reduce it, because the numbers are so large, and both are divisible by 125. So 125 divided by 125 equals 1. And the same here, 1,000 divided by 125 equals 8. So the result is 1 over 8. And these numbers are way nicer to work with here. And now we can apply the rule for the logarithm if you have a fraction here in your logarithm. You can split this logarithm into 2 parts. You take log base 2, so here log base 2 and here log base 2, and you subtract these both. And in the first log, you write the numerator of your fraction, so the 1, and in the second log, you write the denominator of your fraction, the 8. And now you have 2 separate logs, and they're way easier to evaluate. Because the first one, we have log base 2 of 1. What have we learned? Every time we have a 1 here, we're happy to see this because this equals 0. So this cancels out. And then we have the minus. I write it down already here. And this log, we just take the base, the 2, multiply it by itself until we reach the 8. So 2 times 2 equals 4. Times 2 equals 8. It's 1, 2, 3 times, so the 3 is here, and this is our result. So what else do we have here? Okay, another decimal number, but this time, do you see it? There is no base here. Did I forget that? No, it can happen that you don't see a base, but then you have to know which number to fill in. So every time there is no base, you have to fill in a 10. It's always a 10. So log base 10 of this number here. We convert this into a fraction again. So log base 10, which fractions do we have here? We take the number after the decimal point, so this time it is a 1, and write it in the numerator. And then in the denominator, we take a look at the place value of the last digit again, so it's tenths, hundredths, thousandths again, so the 1,000 we write it down here. And now we apply the rule for dealing with fractions in our log again. We take log base 10 of the numerator first, so log 10 of 1, and we subtract log base 10 of the denominator of 1,000. Okay, 2 separate logs to calculate. The first one, easy. There is a 1 in the logarithm, so we know That's great. This equals 0. So 0 minus, I write down the minus already here, and now we have to evaluate this here. We take the base, the 10, and multiply it by itself until we reach 1000. 10 times 10 equals 100, times 10 equals 1000, so it's 1, 2, 3 times. We write the 3 here, and this is our result. Okay, what else? Yeah, this time we have a fraction as a base. This is something different than we had the whole time, but we try to do it the way we did it the whole time. So we take the base, the 1/6, and multiply it by itself. And let's just see if we can get to this number here. So we have 1 times 1 equals 1, and 6 times 6 equals 36. Not really. It's not the 36. It is 1/36. It's similar, but not the same. But don't worry, we will get there. But we know by now already that we have 1, 2. We multiplied it twice here, but 2 can't be the answer here because it's not this number. They are not the same. They are just similar. But how are they similar and how are they different? Well, the 36, if we write it as a fraction as well, 36 is 36 over 1. And here we have 1/36. So this is the reciprocal. It's the flipped version of this fraction. But we can flip fractions by doing one thing. Let's write this left side into a power. So we have 1/6 to the power of 2 we have on the left side, and this equals 1/36. This equals something we don't need here, but it's okay, it's the beginning. So we have the 2 here, and we said, yeah, it's the 2, but that can't be the result here. How can we flip such a fraction? With a simple thing, we just have to change the sign of the exponent here. So instead of writing a 2 here, we write a -2, and that switches the numbers here. So that does that the 36 goes on top and the 1 on the bottom, just changing this sign of the exponent. That is a thing you can use everywhere. So this means that we now see if we take the 1/6 to the power of -2, then we get the result we need here. So the result from this log is not 2, but it is -2. So every time you are close, but you need the flipped version of this, you just have to do a minus here in front of your number, and then you have the result. And now the last example here, we have a fraction as a base, but also a fraction here. Let's see what happens. We multiply the 2/3 by itself and hope to get to this fraction here. 2 times 2 equals 4, so not yet the 16, so we multiply again by this fraction. 2 times 2 times 2 equals 8. Not yet, but once more, then we have 2 times 2 times 2 times 2 equals 16, and 3 times 3 times 3 times 3 equals 81. So we are here. Okay, that was easier than the other example before that. So we have 1, 2, 3, 4 times, and that's the result. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.